This is an old elevator test unit we're going to demonstrate today with sand. Inside a feed hopper is a pair of intake scoops that will feed material into a rotating casing. We'll elevate that material to discharge head. Inside that casing is a static screw. Turn the elevator on and show the working components. Here you can see the intake scoops inside the feed hopper. Rotating casing, we control the speed with a variable frequency drive. We'll take a look inside the discharge head. Here's our feed side of our hopper. And this is our top of our rotating casing. We have a bronze slinger on the top of the rotating tube to direct the product outside of a labyrinth seal. We have a solid pipe inside that our rotating pipe goes through, and then a static screw inside the elevator. Well, we'll put some sand in it now and show you how this technology operates. Okay, we've added a couple of buckets of very fine dry sand to our elevator. You can see that material's in our feed hopper. We have our discharge line set up now just to recirculate material, which we'll do initially, and then we'll run a couple of flow rate trials. Okay, I'm going to start the elevator, and we'll see how it self-feeds. See how the material is drawn in, and we're going to watch the top of the elevator now to observe how the sand exits the top of the casing, and keep an eye out for any dust. And this is very dry sand. I'll even try to get a view right across the top and see if we can see any dust. And we don't. Now this is dusty sand. Where it's discharging back into the hopper, I'll show you. There's a cloud of dust in here. You can see the dust generated from the cascading sand. But again, when we look in the top of this elevator, even though it's conveying dust-laden sand, there's no dust coming off of it. And when we stop the elevator remains full of sand, or whatever material you're conveying. We've set the elevator up now to discharge material into a bucket. Added more material to the elevator. We'll repeat that last trial, but we'll have a look inside the top of the elevator. This is the top of the rotating casing. See the material being intake scoops getting starved now. You see we had a little when we starved the intake scoops, we allowed material inside the casing to drain out past the scoops. That's the only time that you'll find the material draining out of the elevator is if those scoops are allowed to be exposed. I will repeat that last test and we'll stop the elevator before the intake scoops get started. And then we'll take a look in the top of the elevator. You see how the sand remains filling the column. Because our intake scoops are covered, in this case with just an inch of sand. So there you have it. It's the old elevator elevating dusty material without creating any dust. Of the old elevator, we have a demo unit here that uses a static screw mounted in a 4-gallon bucket, and we will introduce the rotating casing which shows the intake scoops that will pick material up out of the bottom of the hopper, and as the rotating casing turns around the fixed screw, it will pull the material into the elevator where the contact friction will elevate the material up the screw, and we'll demonstrate that for you now. Two. Note how the column remains full of material. No possibility for dust to form inside. If we stop the elevator, it remains full of material. If we reverse the elevator, it purges itself. And why don't we restart it again and fill her up and watch how it fills that column. No segregation. We're looking to elevate without explosive dust clouds.